You're listening to the Interactome, a podcast by a group of young researchers who want to connect you to the world of science by sharing their stories and perspectives. Just in case their bosses are listening, they want to remind you that the opinions expressed here are their own. They also want to remind you not to take anything they say as medical or professional advice, as they are not doctors. Not yet, anyway. Stay tuned about that. And, without further ado, welcome to the Interactome.
Hello.
Oh. Hello.
There's a lot of podcasts I listen to that start this way. They like keep the crap at the beginning.
Yeah. All right. So
hi, I'm Sam LaRussa. I'm a PhD student at Brandeis University studying biochemistry and biophysics.
Hey everyone, my name's Lauren. I'm a research associate working at the Broad Institute in Boston.
Oh, I'm supposed to go next. Hey guys, I'm Joe. I'm also a research associate working at the Broad Institute in the Boston, Cambridge area. So, yeah.
Hi guys, my name is Maia. I am a PhD student at UC Berkeley studying molecular and cell biology.
Yeah, welcome. This is our podcast. We are still trying to figure out a bit about what we do and who we are, but we have a bit of a vision for this. This is, I think a lot of people in science communication, they like to share information about like what is happening in science, but I think the pandemic has really shown that it's really important that scientists and people who aren't scientists just get a chance to know each other. And so that's really what we're all about. This is, I think we've decided to call this the, or Interactome Media is the name of our group here because at least in my mind, and you guys feel free to jump in here, an interactome is, in biology, is a term for a lot of things that all work together, like in a whole system to create a functional thing in a cell. So like a system of a lot of different proteins, which are basically like the workhorses of the cell working together to help cells live and grow. But in the context of like us, I think each of us is like a node in that in a network of just information and ideas and things like that. And we want to be a part of that and be in an interface between science and society.
The ohm part is
ohms.
So interacting
ohms.
is probably pretty obvious. But omics. So it's a little bit less popular now. But when we were all starting out in undergrad, starting out just like college and getting our bachelor's degree, omics was like the best way to get funding. so the joke there is you would, but what it means when you stick like ohm at the end of it, it's like, you're not looking at like one protein, we're looking at the proteome. It's the collection of all of them. And so like omics is like kind of like the study of like all these things as a group or as a like an overarching view of what's going on. So genomics is, what's going on with the whole genome, like the whole gene, all the genes. So like you have gene, and then they all make up part of a genome. And so, you have interactions, and then they all make up part of an interactome. You have proteins, and then all the proteins in a cell or in an organism are the proteome.
And I think that's like the vibe that we want to go for. Like we as like nodes in our interactome like want to connect with our audience, and we want to help you guys make connections to different things you might hear about science on like the news or from your peers or other places. We want to like make science more accessible and understandable. So you guys have or at least like science is like less scary to approach, and you feel comfortable hearing and learning new things about science.
Yeah. Science is a thing that people do, and I think that that's like kind of what I want the important, or I think this goes for all of us, is like that's what we kind of want to point out, is that science is not a thing that exists in textbooks. It's a process, and it's a process that people do. And this is to try to highlight those people. And we are 4 of them, but there are lots and lots and lots of us. And hopefully in the future, there will be other scientists coming out of this and talking about what they do and what that's like.
Yeah.
Yeah, I think like overall, we just want our audience to feel connected to the world of science in a way that is digestible and not intimidating. I know personally, I have a lot of friends and family who will reach out to me, especially with COVID. I think this is, as Joe mentioned, like really highlighted the importance of like open and digestible science communication. I have family members who were really concerned about the vaccine, really concerned about all these treatments they were hearing about. Like at one stage, like what is COVID? What is a virus? Like what do all these statistics mean? So I think that as you know, by creating this podcast, we're kind of inviting you into our world and like our interactome. And hopefully that just makes the world of science more inviting for the general public.
Yeah, and I think the other thing is, I think like I personally, and I think this is the case for everyone else, like I don't really want this to be a just us sharing our stories with you. I think as we go along, maybe this will develop more into a sort of community or things like that. And I think it's helpful for us as scientists to hear the perspective of other people as well. Like, because our goal at the end of the day, at least for a lot of us, is to like uncover new knowledge to help make things better for a lot of people. And I think a lot of us listening to this have, we've all benefited from something scientific in some way, but in order to make science helpful for everyone, the people who are doing the science need to understand who they're trying to help. And I think that's really important too, that we as scientists don't become disconnected from the rest of society. And I think that's something that isn't really, I think, discussed all the time, but that's a thought I've been having.
Well, and like things have gone wrong with that in the past. Things have definitely gone wrong with that in the past. There's a reason why a lot of people don't trust science, and that's because, you know, we talk a lot about, like now in science, in the scientific community, talk a lot about ethics. I think all of us have probably had multiple ethics courses and things on like, you know, what's the right way to do science, and that wasn't always the case. And so there has, you know, historically been a degree of breakdown in these relationships. Partly, I mean, I was thinking about this, like where science came from. It almost makes some degree of sense. So science is a process for finding out information. It's, you know, there's a scientific method and you work through it to develop hypotheses. You know, you get ideas of how something works and you test them. And that's, you know, there's more to it than that. But for the most part, that's how science works. But the people who are doing this, you know, 100 years ago or more were, you know, rich people who had their own little kind of societies where they were doing these things and be like, ah, yes, I found this strange rock and I boiled it and it did this thing. Or, like, but the most ridiculous example, I forgot the guy's name. But there was a guy who boiled his own urine and discovered phosphorus.
What?
White phosphorus. Yeah, the discovery of white phosphorus was done by a guy who was living in Dresden in the 1800s. I can like look this up.
Oh my god!
But
sure, everyday 1800s activity in the lab.
Wait.
So white phosphorus is incredibly dangerous.
Yeah.
And so Dresden was actually later burned to the ground using white phosphorus. In one of these strangest, Hennig Brandt, the guy's name. He was
oh my god.
Oh, this was not the 1800s. This was 1669.
Wow.
way earlier than I thought. And he was trying to turn, you know, like lead into gold or whatever, and he's like, ah, yes, urine is gold. But like science
Same
has a pedigree
color.
stemming from these people just doing things because, instead of being people who worked the land or like, they were, at the end of the day, probably rich people screwing around. And they were following us. Well, I don't know if Henning Brandt was following the scientific method all that strictly. I don't think it existed back then. But you get these things where it's like, ah, yes, we're just screwing around. But then when biology started getting big, then you started doing this to whole populations of people, and it didn't go well. And I think that that's like something that has to be said if we're going to be talking about relationships between people and scientists. Like, yeah, you
Yeah.
got to acknowledge that
I
this.
know people, yeah, like people like to say that like, oh, science is, like science is science, but like in actuality, like science is very much affected by like societal constructs and the economy and several things. So it's not just science, it's affected by a lot of things, and there are a lot of problems in scientific structures today too. And I think it's good to be transparent about that.
And I know that like at Brandeis they talk about this a lot, and I know that I interned at the Broad a bit undergrad, and they talk about this a bit there too. I don't know what it's like at Berkeley, but at least the institutions that I've had the opportunity to go through in the Boston area, they all seem to be fairly aware of this, and they're trying to incorporate that into how they govern themselves. And I think that's probably happening around the country, hopefully.
Yeah, that's good. It's, yeah, there's a lot to be
Yeah.
done, I think.
But
I agree with Maya, and I think historically scientists are human, but they have, especially in the biomedical field, like reinforced stereotypes, reinforced social beliefs,
Yeah.
and scientists have contributed to racism and sexism in their own way, in a
Yep.
way solidified it because they are scientists. And so in a way, so on one side, we are promoting science and we are trying to, share our knowledge and our understanding of science. But on the other hand, you need to also be aware that this is science carried out by humans who have their own implicit biases and humans who make mistakes. So I think everything we have to take with kind of a grain of salt. As much as I love science, I think it's important to recognize that it's not perfect either.
And I think that like what I was trying to say is I think that this is like it's an ongoing conversation, and I'm seeing that happen, and that is that feels good to see that like this is what scientists are talking about now. It's not just like the metaphorical I boiled the rock and it did something cool. It's like, okay,
Yeah.
how do we make sure that this is equitable? And especially right now, we're seeing that at least on the public health scale that's still not the case. There are still things that are going wrong. And the question of how to address that is an ongoing one, and it's not going to be a problem that's I expect to be completely solved for a very long time. I mean, people are people, and scientists are people, and
Yeah.
Yeah, and I think it's good to be transparent about that with our audience.
Absolutely. I think for at least my opinion is that like, how do you actually know something? How do you know that what you know is actually true? And I think that is one of the things that science is really good at answering if done well. Like you can develop an experiment that like ideally, like when you make a manipulation, when you add a chemical or you change one condition, you see a result happen. You see something else happen as the output. And because you have designed your experiment in such a way that it rules out all other alternatives, you can actually, provided that you can repeat the experiment and get the same result, know that what or like your rationale behind why you are getting the result you are getting is actually true. Like, or maybe a better way to articulate this is that science is a way to actually know what is, or at least the scientific method is useful for knowing what is causal of other things by ruling out alternatives. And of course, there might be things that you're not thinking of when you design an experiment. Like, if I'm testing things in my cancer cells, like if I'm throwing drugs at my cancer cells to see if they die, and I see them die, I know because I had a solution that I added with drug and a solution that I added without to a separate sample. If I see that only the solution with the drug killed the cancer cells, then I know that it's the drug that killed the cancer cells. But it might be that.
Well,
Go ahead, Sam.
I was just going to say, it's like that there's always, there's always some unlikely options on the table.
Absolutely. But so science is, at least in my eyes, it's not perfect, but it is one of the best ways that we have right now of getting as close to what is true as possible.
And
oh, yeah.
The other important thing about science is you can say your drug killed the cancer cells, and I can go prove it to me. And that's how science works. Is, you go to your boss, or you go to a peer reviewer, or you go to the FDA or whoever it is who's like reviewing your work, which happens. That's how science happens. Is before science like gets out to the public in whatever way it is, whether it's a publication or it's a drug or whatever. There's usually someone who goes, prove it to me, and often they will even start asking questions like, well, it's like, okay, Joe, well, you said that drug was the only thing you added, and you sure there wasn't a contaminant in there? You sure that drug was pure? Can you show me the purity results for that drug? Because there could have been something else there, because I know that manufacturing processes could add this thing and this thing, and like this thing will go on for forever. But
yeah, Pixar didn't happen.
Yeah, Pixar didn't happen. But like, not iPhone pictures. No, we're talking like fancy, expensive, like DSLR. Oh, forget DSLRs. I mean, even my cameras aren't that good. But I think like, I think that for me, that's why I wanted to go into science. I think it was partly just because like I like to know how things work, and so like this question of like, how do you find that out? I mean, that's science. So like, I was constantly taking stuff apart as a kid and stuff. So like, for me, going into science was like a way to answer these questions about like me and the world around me, and be like, okay, I got sick today. Why did I get sick? Like, what are the ways to answer this question? And of course, it's not, Henning Brandt boiling his own urine time. I mean, we have to like, there are rules, and it's also impractical to do tests on yourself, and you probably shouldn't be. That's not particularly scientific, but
I mean, you can. People won Nobel Prizes that way.
Yeah, I mean, there was a guy
self-inoculating.
We do not endorse this method, however. Just putting that out there.
No, the guy gave himself ulcers, first off.
Yeah.
And like, if you don't know what you're doing, you can hurt yourself. I mean, there's like mess around and find out is not. Well, also, if you're not healthy to be taking notes, it's no longer.
Like, are we not dedicated enough scientists that we're not swallowing the compounds? Like when I see what they did in like the 18 and 1900s, I'm like, wait, I'm not a hardo enough. I like need to science harder.
But it's not like responsible. But it's not irresponsible necessarily if you're doing something yourself and you're a researcher who's really studied something or whatever. But like, for the most part, even then, it can be quite irresponsible, because like, I'm a biochemist. I don't know. I barely understand how a cell will respond to it. I don't understand how the trillion odd cells or whatever in my body are going to respond to that. I have no clue. That's not the scale I work on. And so like, the reason why drug development has these massive teams where you have, biochemists like finding compounds, and engineers formulating stuff, and you have, cell biologists who are testing it, and animal technicians, and then you have the clinical people, and then you have FDA reviewers, and like the actual like MDs who are looking over all the stuff as part of the clinical team. Like, there's a reason why this is happening, because the clinical team isn't going to be sitting there like parsing out all these little biochemical things that I'm going to be spending, tons of times working on, and so on. Like, so like, if you test something on yourself, you're not the whole team. There's, you need lifetimes of experience to know whether or not, drinking this strange thing is going to really work. And sometimes it might, and sometimes it, doesn't work, but you're lucky and it doesn't kill you. But but like, is that really something the average person wants to mess with? And I think the answer to that should be no. Unless it's like, oh yeah, it turns out that this thing that's already on the market happens to help with this. I think we all do that, where it's like, oh yeah, I get this stomach ache sometimes. If I take, a Tums or whatever, it'll go away. We all do that. And like, I think that that's like a normal thing to do. It'd be like, yeah, okay, my body responds a certain way to this, but that's like your own personal relationship with medicine. And hopefully you have a physician who you mention this sort of thing to, but it's not the same as developing a drug or understanding how the body works. It's a totally different process. And there's
the other thing that
Yeah,
oh,
that reminds
yeah,
me
go
of
ahead.
something.
No,
Like,
no,
go ahead.
no, you first.
Oh, yeah, kind of like what Sam brought up is like, I don't know if this is like super obvious, but science is built on collaborations. On, like Sam was mentioning, like you have entire like different teams, people with different specialties, like all working to like develop a drug, and it's true for like a lot of several areas of science that the only way you can kind of like get closer to the truth, that's like Joe was saying, is that if you work together with other people and share your ideas with them. That I think is a very beautiful idea. I like to think of it as like we're all like pieces of Swiss cheese, and like we all have like holes in our knowledge. But when you overlay like pieces of Swiss cheese, like those holes will get filled by like people that like know different things than you do, and you like help each other out. And you get a fuller cheese or like a bigger picture of what you're studying. So
I love that. Yeah.
yeah, thank you.
That was good.
I really love that Swiss cheese. And
Yeah,
this
this was actually it was the analogy that my PhD program gave to all first years that are entering, because our program is like a very broad, like interdisciplinary thing. So we all come from like really different backgrounds, but we all take a class that kind of like gets us up to date on like different areas of biology. So it's like neuroscience, immunology, cell bio, and biochemistry. And so like obviously we're like not all experts in that, because like who has time to like be fully versed in all of that? But our advisors were like, oh, you're all pieces of Swiss cheese. Like someone will be good at neuro and someone will be good at immuno, and like you guys will help each other out. And that's like, the spirit of science, collaborative energy.
That's also what I love about science. And I found like, even as I've like entered into the working world of science myself, I really love the sense of collaboration. I also just think it's very humbling to just be like, okay, this is not my specialty. Can you speak to this? And just being able to recognize that you can't do everything yourself, and you can't do everything the best. But collaborating with other people who know how to do it more efficiently, how to do it better. I just think that's like such a beautiful thing in science.
Yeah.
The teamwork.
That's like big interactome energy right there.
Teamwork makes the dream work.
Yeah,
guys, I have a thought on the title for this episode. It should be "We Are Swiss Cheese." That's absolutely what it should be. I don't know.
That's
fantastic.
I like it.
Maybe
I like
for those of you who are listening wherever we're actually putting this, if the title is not "We Are Swiss Cheese," we apologize. There's probably a reason that we chose a different title if we did.
I think I might have explained it. I think like one block of Swiss cheese, like if you slice it, it has holes in all the same place, but we probably have to come from different blocks of Swiss cheese, because like the holes are probably different in each block. I don't know the probability.
I'm not a cheese expert, but I'm imagining that they're spherical and they're interspersed throughout the whole thing. So like you could just slice it and like stick the slices back together. So you could look slice like a pizza and put them all. I don't know.
Yeah, I forgot that cheese comes in like ovals. I don't know.
This is an elaborate analogy.
Yeah, I thought it was like
very
a loaf
distracted
for some
reading
reason.
the Code of Federal Regulations pertaining to cheese at one point. I like cheese documents. They're fascinating. Speaking of science I don't understand, this cheese science is just a fascinating thing.
I honestly think that like being a food scientist would be really bomb, and it's definitely really relevant now as we're like coming up with like alternative meat sources in light of like
I have a friend actually just moved to the Bay Area, Maya, who's doing food science stuff.
Oh, great.
Maybe we can get her
Yeah,
on
that'd be
here.
cool.
I don't know how much she can talk about.
Oh, that'd
'Cause
be cool. Like a guest
she's
speaker.
in a
Yeah.
corporate.
Oh,
Oh, is it like Impossible Foods or
yeah,
something
yeah,
else?
yeah.
Oh, cool. Okay. Yeah.
Yeah,
That's
so
cool. She could help explain exactly how it works, because I think people freaked out when you say lab grown food or
well,
Yeah.
Impossible Foods.
yeast-based food.
Yeah, it's
or-
the recombinant. I think it's leg hemoglobin. I find it fascinating.
Yeah.
I gave like a whole
It's cool.
speech impromptu at an interview, just with like the grad student interviewers here. I didn't know this had nothing to do with me getting into the program or not. Or I got an Impossible Burger and I'm like, this is cool. I should watch my language. It's getting late, and I should be watching my language.
Is this podcast rated PG-13?
I can bleep that out. I can find a good bleep. I could even find have a sheep noise or something.
Oh, perfect. Yeah, that'll be funny. Like some censor.
yeah.
Yeah.
Maybe.
Yeah.
We'll have.
Oh, go ahead, Sam. Sorry.
Oh, I was gonna say we'll have Margaret transcribe, and she'd be like, "Sam, you swear it here."
Maybe one thing I know Sam already mentioned this, but maybe the rest of us should share with everyone who's listening a bit about like why we do science or why we're in it. And I think our why is kind of evolving for a lot of us because we're all learning. Like we don't know everything, but yeah, I mean for me, like I really like the first thing I remember about science was opening like an anatomy book when I was 5 years old and reading that you can take your small intestine and stretch it out over the size of a tennis court if you take like the full surface area, which I thought that was really cool. I was like, whoa, that's so weird. And then my mom was like, Joe, I don't want you seeing that. Like I don't. I'm taking this book
after
away.
that vaguely traumatic.
Yeah, I'm taking. She was like, I'm taking this book away from you, and I was like, no, but I want to learn more. And so like I understand like now a little bit about like there may be reasons why she took that book away from me, but also like the little kid in me was like, no, I want to learn more. And so like initially I started thinking about science. I like to joke that it was almost out of spite, but like now the reason I'm here is because it's one really exciting and it's really cool to know that you like in a lot of cases if you're a little lucky in a lot of cases, or if you design things well and if you think clearly, you can really contribute to helping progress a lot of different things, health, society, things like that. I mean, you have to be careful, but science is a real opportunity to make things better in a way that they weren't before. Of course, my thought is also that like you have to consider ethics because any new discovery also opens a whole new can of worms. So you just gotta, I think there's an element of character that's important in science, but yeah, I'm going on a tangent. I'm here because I like it. I think it's cool. Honestly, I feel like when I'm playing with my molecules, I feel like I'm playing with science Legos, which is really fun. I get to tinker with things, and that's great. But also just like the opportunity to really help people that like I think should be helped, like seeing people close to home like really suffer with different kinds of illnesses or not be able to do something that they would like to do. Science can help with that in a lot of cases. And yeah, also I think it's exciting like going to space or things like that. Like we can do that because of science and engineering. Like we put someone on the moon, and we'll probably do it again at some point. I don't know. That's exciting to me.
I have to go.
Oh.
Sorry.
Oh. Do you have a second?
But it was nice to hear you.
Do you have a second to share your why a bit, or do we want to wait?
Oh yeah. I can probably give like a brief. Yeah, I think taco night is underway, so I get a little nosy, so like, that's why I'll go. But yeah, I was very yeah, I was really lucky to have a parent as a scientist growing up. So when I was little, like I would look through our bookshelves, and there would be like biochemistry textbooks and virology textbooks and different things like that. And like when you're a kid, you know, you're curious and you like open random books and see what's in there. So of course I like didn't understand like any of the words that are in there because I was like 4, but I remember like coming across this picture of a T7 bacteriophage, and if you guys don't know what that looks like, it's like a really cool looking virus that infects bacteria, and it's kind of like it's like it has like a hexagon for a head, and then it has like a long body and then like legs coming out of it, so it looks like an alien invader. So apparently I like that image so much that I asked my dad, like I kept on asking him, like, can I borrow your book again? Because I want to look at the picture of the space invader. So I looked at it so many times growing up that he put a sticky note on that page for me so I can find it whenever I wanted to, so I could go look at it. So I think that began my love for tiny things. So I think it really took off in college when the curriculum for biology starts to get more molecular. So you look at like proteins and RNA, different like tiny things inside our cells. So I all thought that was like really, really rad. And I guess like something else that tied into it was because I, similar to a lot of people, I'm really curious about how things work. I'm also someone that's really hands-on. So I'm also an artist and I do the illustrations for our Interactome Media shindig. So I really enjoyed working in a lab, trying to manipulate these like tiny things. And it was just the coolest thing ever for me. And to draw another connection between science and art, which are both really important to me, I think science is a really good opportunity to be very creative. Um, and it's, I guess like I view it kind of differently, but I like am a basic science researcher, so I'm like really interested in finding out how foundational foundational ways that like biology works. So I think it's really exciting that there are just things that we'll never know, and it's in that way like science is kind of like propagatory, if that's a word. It just propagates itself because every time you find out something new, you come up with more questions, and it's just really exciting to be able to be a part of that. Yeah, so that's me. And
Yeah, honestly, Joe and Maya have kind of touched on both my whys. I can't pinpoint some cute story or like some childhood memory as to why I science. Neither of my parents were scientists or involved in that aspect. I think for me, it has mainly been the discovery aspect of science, like the fact that through science we're learning something new. Um, that is just like that's what's kept me coming back to science. I also love I'm a nerd and I love the like procedural aspect of science, of setting up experiments, carrying out experiments, doing it well so that you can be confident that what you do, what Joe mentioned earlier, that like we set up experiments and we carry them out in a manner so that like when we do see something happen, we are able to confidently say it's because of this drug or because of this protein that we're seeing this effect. And just like learning something that no one else has known before and knowing that you're contributing to um, yeah, a little piece of the puzzle is really something that I find fulfilling. And yeah, I just overall love science.
Yeah, I think that like
Yeah.
being the person who's done something for the first time is crazy.
Yeah, it's wild. And it's like, yeah, I find it really exciting.
we're all
I get
doing that,
excited by data.
obviously.
Like, I love data. Every time I run an experiment and it's like going to give me any sort of data, I'm like, okay, let's do it. Well, thank you so much for tuning in to our first ever podcast as Interactome Media. We are so grateful to all our listeners for tuning in, and we hope that you are able to walk away with some valuable information from this episode. Please let us know if you have any questions or comments, and share with us what you'd like to see next. We plan on interviewing scientists and covering a broad range of topics. So who knows, your suggestion could lead to the next node in our Interactome. You can also find us on YouTube under the name Interactome Media. We have a website, interactomemedia.org, and we're also on Instagram and Twitter with the handle @theinteractome. Thanks again for tuning in, and we can't wait to share our next episode with you very soon.